Relations and functions. All right, there are the domain and the range. Those are two terms you need to know. And the domain is just going to be all of the x values. So domain is all of the x values, and range is all of the y values. Is there a memory tool for that? Sure there is. So your memory tool it's an ABC order. So think x comes before y. So x comes before y, and d comes before r, d meaning the domain and r meaning the range. So it's an ABC order. Alright. Now that we know what domain and range are, we need to determine if they are called relations or functions. So we're going to start labeling them. And here we are. Yeah, relations are kind of like that. They're next to each other, they're related to each other, they hang out with each other. So what does that? Well, ordered pairs do. So relations are ordered pairs. And the reason ordered pairs are is because x is related to y. So x is related to y, so look at our example, 3, -2. 3 represents our x, -2 represents our y. So if we're relating x to y to each other, it's always going to be a relation. So any graph that has ordered pairs, any set of ordered pairs is going to be a relation. Well, that's easy enough, but what about functions? So functions are when the domain or the x doesn't repeat. Well, there's got to be a better way to remember that. Think, don't go back to your x. It didn't work the first time. It's not going to work the second time. Alright, so functions don't go back to their x. So the x values don't repeat. Alright, and there's one more way to remember functions. What if we had a graph, or we were graphing ordered pairs or a line? How could we determine from looking at that graph? Alright, here's our second way, and I'm just going to label that. That was my first way to check it, is just to look at the x values, see if they repeat. The second way to do that, so the second way to determine if it's a function, does it pass the vertical line test? That means it never touches more than once. Alright, let's come up with an example for that. Okay, go ahead and draw a y-axis and an x-axis, and it doesn't need to be very big. We're just going to make that take up a few units to the right and to the left and up and down. Next, I'm going to put a point right 1, down 1, or 1, -1. And then I'm going to put a point right 3, down 1. And then I'm going to put a point left 1, down 2. Alright? And now you can take your pencil, we're going to slide your pencil across, put it vertically, like this. So you're taking your pencil, I'm taking my vertical line, I'm just going to slide it across. It crosses once there, crosses once there, crosses once there. So it never touches more than once. So for this first example, we're going to say for example 1, it's going to be, yes, it is a function. Is it a relation? Yes, it's a relation. Alright, let's try another one. Make another graph. And for example 2, now let's do right 1, up 1, or 1, 1, right 1, down 2, and we'll do left 1, down 1. Alright. Now we're going to take our pencil and we're going to vertically put it vertical and just slide it across. It crosses once right there. Oh, it crosses twice right there. So since it touches more than once, we're going to say no, it's not a function. So if it ever crosses more than once, it's not a function. And think back to what we just learned. We said they don't go back to their x. So look at your graph. What's the x value in this situation? It's right 1 and right 1. So the x value is 1, and we have 2 points that have an x value of 1. So it went back to its x. So it's not a function. Another way to think of a function, for whatever you put in, or your input, which is your x, it's always going to give you a predictable output, or y. For instance, if I plugged in a 3, I might get a 4. But every time I plug in a 3, I'm going to get a 4. So that's why you can't have multiple x values there. Each input's predictable. Alright. Next we're going to take a look at ordered pairs and see if they're relations or functions. Alright, example 1. Is it a relation? Is it a function? We're going to copy down 2 comma negative 4, 3 comma 5, and negative 1 comma negative 4. Alright, so for it to be a relation, it just needs to relate x to y. Oh, well these are ordered pairs, so x is related to y, so I'm going to say, yeah, it's a relation. So it is a relation. And now to determine if it's a function, functions don't go back to their x. That's not functional. So I'm just going to underline my x values. That's all I care about. Never mind that the negative 4s repeat. That doesn't matter. I'm just underlining the x's, the 2, the 3, the negative 1. And now, did we go back to our x? Did anything repeat? 2, 3, negative 1. They're all different, so that means it's a function. Alright, so I just look at the x's. If they don't repeat, it's a function. If I go back to my x, it's not a function. Alright, you guys try example 2. We'll do one just like it. Let's copy this down. Alright, same question. Is it a relation? Is it a function? And copy down negative 2 comma 6, 3 comma 2, and negative 2 comma 1. I'll give you a second to write that down. You can pause the video and answer it. And now, let's check to see if you got it. And you should have got it. It is a relation because it relates x to y. But it's not a function, and if you were to explain why, you'd say because the negative 2x value repeats. Did you get that right? Alright, next up we're going to do a mapping. So the same idea, we're just going to represent our domain and range a little bit differently. Whoops, that's the wrong map. Oh, there we go, that's much better. So this mapping is taking the domain and mapping it over to the range, or drawing arrows from the domain to the range. So write down domain and then negative 2 and then 4 underneath of it, and then range negative 6, 1, and 3. And we're going to draw arrows from the negative 2 to the negative 6, and then I'm going to draw an arrow from the 4 to the 1, and I'm going to draw an arrow from the 4 to the 3. Now ask yourself, does this relate x to y? Yes. So this would be called a relation, because your domain is all your x values, your range is all your y values. And next up, is this a function? Well, we could write ordered pairs from this. This is 2 comma negative 6, 4 comma 1, 4 comma 3. Did we go back to our x? Yeah, we used the x twice. So we used it here, and we used it with the 1 and the 3. So it's not a function because of the 4 was used twice. So we went back to our x. Alright, that's our first example with mapping. And we're going to do one more example to jot down. Here's example 2. All right, for example 2, write the domain and then -3, 4, and 7 underneath of it. And then for the range, let's write 2 and then 5 underneath of that. Now we're going to draw some arrows. So let's draw the arrow from -3 over to the 2. And from from 4 we're going to draw it also to 2. And then 7 we're going to draw to 5. So we're mapping the domain to the range. So does it relate x to y? And do any of the x's repeat? I'll give you a second to write down if it's a relation or a function, and then we'll check it. All right, let's see how you did. Yes, it's a relation because it relates x to y. And yes, it's a function because look, none of our x values repeated. -3 was only used once, 4 was only used once, and 7 was used once. So it is a function. All right. Let's sum up what we've learned. Relations relate x to y. And we don't go back to our x. That's just not functional. Didn't work the first time. Not going to work the second time.